questions. There will be a link posted in the chat that you can use. It should be quite self-explanatory. It's basically you can write the question and you can see all the active questions and you can like questions. And then we who are organizing here can pick up questions as they come. The link is, I think, in the chat now, so you can take it there. Yes. Yeah, I think that's about it for the technical details. So let's get going. On behalf of the AEGIS and Moses projects and the technology platform ALICE, I'm very happy to be moderator for this webinar today on standardized cargo units. We will try to follow the program more or less as it's in the distributed plan, but I think it's worthwhile having a few questions after each presentation and also during the panel discussion. So I will be a bit flexible with respect to time. So so you shouldn't trust exactly the timing. So the background for this webinar is basically that yeah, ships and trains for that matter, we have a problem because we are stuck with fixed terminals when we transport cargo, and we in most cases need to have some last mile transport to and from senders and receivers of this cargo. And the transshipment between ships or rail for that matter to trucks, which is typical last mile transport provider, it's expensive in general. In Norway we have a saying, and I think it's quite common in Europe also, that if you have something on a truck, it tends to stay on that truck. So this idea of transferring more cargo from road transport to waterways is tricky, and we see it in Norway in that even though we have ambitions to increase cargo on sea, it is actually losing market shares, and this is also the case in Europe. So, and in the AEGIS project, and I think also in Moses, we are looking quite much on the cargo handling, because that's in a sense is one of the keys to making waterborne more attractive. And one of the questions that come up is that if you try to stretch the supply chains on the water further into the hinterland, you have to use smaller ships, you get even more cost constrained, also weight constrained. And the question is, do we really need all these different types of unitized cargo? Is it possible to standardize it? Is it possible to have smaller units, for instance, modular units? And this is basically what we want to investigate. There are very good reasons for all these different cargo units, of course. And it's not trivial at all, if at all possible, actually, to do something on this standardized cargo unit. It has been attempted before. But anyway, that's the question we have posed to our presenters, which will also discuss this issue in the panel. So I think we just start with the first presenter, which is Fernando Liesa, which is Secretary General of ALICE. This is the European Technology Platform for Logistics and Supply Chain Management. And Fernando will present his viewpoint on what constraints autonomy and the green initiatives will either create or remove, for that matter, in the logistics industry. So please, Fernando, do you want to take the screen yourself, or?
Yes, I'll do that. Hello, everybody. I have prepared a few slides, so then now I'm sharing them. So there are all of AEGIS and Moses partners, ALICE members, all good morning from today. It's sunny Brussels, and that's always good, particularly in Monday's morning. And it's a great pleasure to us, Alice, to have co-organized this webinar, as Ornulf was saying, with these two projects, Moses and AEGIS, that are liaised with Alice. Indeed, through our program of liaison with projects and initiatives, we support them to connect to other projects. And for example, when preparing this webinar, we connected to the project Clusters 2.0 that is also participating today in this session, and also to the industry roadmaps in order to accelerate innovation. And as time is very limited, I will not introduce Alice and will go directly to the point of our meeting today. And as Ornulf said, I have been asked to bring the broader perspective into the discussion. So I would like to start with the disruptions that the COVID-19 has brought not only to our lives, but also to the supply chains. Many supply chains were practically stopped for a while others were surging because of the need of healthcare or other goods. And also created like some in manufacturing or ports were closed, these facilities, and this created a lot of imbalances. Of course, additionally to this, climate change is more and more in the agendas of governments and companies, and indeed we need to act fast. And we see all other issues and well-known lasting problems that are becoming acute, like the truck driver shortages, and also all what I mentioned before is creating fulfillment problems in our supply chains. Components are not available, slowing down or even stopping supply chains. And also we have additional issues making container freight rates skyrocket. So the question here is which will be the next wave? How to face these continuous disruptions, and could we find opportunities in here? And actually today we will see different examples on how we could approach this from a different perspective. So we indeed see certain limitations in the approach, as in most cases we think the future must look the past, and we are trying to drive a car only looking into the rear mirror. And very happy Rod Franken is with us here today, because he usually reminds us in our discussions in ALICE of this aspect. So then the question is that why do we do that? I think it's a matter of inertia or trying to find easy solutions, but probably it's not enough. Currently it's not enough, and also it's not appropriate. We have many opportunities, as for example will be presented today by AEGIS or Moses, becoming on these autonomous systems. So then why do we need to constrain future autonomous systems into how we use current systems? And this is what we will discuss today. And indeed here it's also very important, because we had our logistics and supply chains working well for a while. We knew the answers to the questions, but suddenly the questions have changed, but we still keep trying to answer in the same way, and that's probably if the questions are changed will not work. So what we are doing in ALICE, or what we are trying to do or what are we trying to strive for the future? Before the EC published the Green Deal, we published our roadmap towards zero emissions. And we see now the focus in governments is on transitioning fleets and assets and energies to use low or zero emissions technologies. And this is very important, particularly for the long run, 2050. We need to make sure all the assets and energies are zero emissions. But this will not give us the benefits in the short term. So then Why? Because the technologies are not mature enough, and this will not. This will take time to be the case and make this affordable. So then we need to act fast and look into low-hanging fruits and opportunities when possible. And the question here is where we think more focus should be given is how we can better use the assets and vehicles, how we can really transport more with less, how we can make the use of other transportation modes easier and faster to access. And here I think the projects we are discussing today have something to say. And indeed, in order to do that, we really consider one of the main problems or barriers is that the lack of interoperability between the transportation modes, physically and digital. So then it's very complex to access resources and assets in the supply chain, and that's why we created our roadmap towards physical internet. So then we can create that interconnectivity, making a better use of the transportation system. And why? The first thing is that we need to make, or we need to, as we will discuss today, how we can make our resources interoperable across supply chains. I mean, vehicles, load units, and boxes. So then we avoid problems when we have a fluctuation in one of the supply chains. We can have another supply chain that is growing, but we need to be able to use those resources, or we need to make sure or make it easier for different flows of goods to be combined, so then you can rebalance that. Then also because when we have more interconnectivity, and I think here autonomous systems can provide more flexibility when we are talking about autonomous fleets into the system, how we can reposition those fleets and assets, how we can really find alternatives when one of the connections is disrupted. So then when the benefits of having a truly integrated transport system, and also how to access in an easy way to the resources and the services. And here I have been discussing with AEGIS and Moses partners, there is a lot of complexity to really make it appealing for new flows, or flows in particular, some resources like smaller terminals to the current practices in salt sea and inland waterways transport. And I think here is what we will discuss today. That I think both AEGIS and Moses, but also Cluster 2.0 are addressing these physical and digital interconnectivity issues. And maybe AEGIS, and today we will focus more on the physical interconnectivity, how we can have the modular loading units working as a family, and that can be handled in an easy way in bigger or small terminals, in bigger or small fleets, and also what can autonomy provide? Do we need to have big ships when they are autonomous, or could it be better to have, or simpler, easier to have smaller ships, and then this could provide a little bit more flexibility? This is one question that we will address today, I think. And also with Moses, we see the focus is on how to make it easier access to the services, so then to attract freight transport to salt sea and inland waterways transport. And then I think we will have a very good example from a project Cluster 2.0 on how they have worked on this in a different transport mode. But in our idea is that the more compatible the units, the vehicles, the assets, the resources are to the different transport modes, the easier will be that are better used, and then we can really work on a future supply chain. And that's all on my side as a short introduction. And thank you very much for your time, and looking forward to the discussions.
Thank you very much, Fernando. I don't see any questions yet, but I think you raised a couple of important issues that also we are concerned with in the projects. And one is this economy of scale. I was asked some time ago what was the killer application for autonomy, and I think perhaps it's the possibility of building smaller ships. That is a very interesting opportunity. But that again will have an impact on the whole supply chain. I think you will have to think differently, as you also say, Fernando. And the other is this silo thinking. I think it was a term I found on your web page actually, that logistics seems to be quite compartmentalized still. There's not a lot of integration. I'm not sure if you have any additional comments on that, or
only to say that both aspects are constraints that we have had into the past. I think logistics and supply chains are complex by definition, and the only way to address complexity is trying to divide and conquer, and that's what we tried to do in the past, and it worked very well, and I think it's appropriate. But on one hand, we see in this global world, this is making it sometimes not as flexible or resilient or responsive as it should be. And we also see there are many other technologies and possibilities to address more complexity at once. So then that's why I think it's we need to look into the transition. For example, the example you said, why, and this is my example or road saying, why do we need to look into the future as to the past? So then is this that autonomous vessels have the same requirements? Do they need to be as big as possible, or there is other benefits of the autonomy that can really make the economy of a scale of bigger asset be counterpart by other benefits of flexibility or easy access to different points or different terminals? I think those are very good questions that you are trying to address in both projects.
Yeah, we'll see. Maybe Harry Laus have some answers. He is a professor at the Technical University of the Denmark, Department of Technology, Management and Economics. I think it's quite well known, so I won't use a lot of time on this. He is, or DTU, and Harry Laus Psraftis is participating in the AEGIS project, and one of the things they are looking into is this particular problem of what are the possibilities actually for using more standardized cargo units. So please, Harry Laus.
Thank you. I will try to share my screen. I don't know if you can see this.
That's fine. Thank you.
All right. So I will try to do three things in my talk. Number one, introduce the AEGIS Horizon 2020 project, and then we have a task on AEGIS that deals with standardization, and report some preliminary results. And there is no secret that the EU has a policy, a major policy to shift traffic from road to greener modes. By greener, I mean rail and water. This has been a pillar of EU transport policy for many years. But I want to put this graph for you, which is a bit a source of concern. It shows the horizontal axis here is time, and the vertical axis is billions of ton-kilometers. You can see here road is number one, then followed by sea transport, and then rail is way behind, and then inland navigation is somewhere there. What is more concerning is that the growth of road transport between 1995 to 2018 is much higher. It's higher than the growth, the equivalent growth of sea, and much higher than the growth of rail. And to make things worse, most of the greenhouse gas emissions are due to road transport. It's about 72%, and then navigation is 14%, and aviation is 13%. So road emits more greenhouse gases. The question is, how can that be reduced? The general strategy is twofold. Number one, have greener vehicles for road, like electric vehicles, for example. And the other is shift traffic to greener modes, like rail and sea and inland navigation. And then we have the Green Deal that was presented a couple of years ago, which has some very ambitious goal about making things greener in the European economy in all sectors of the economy. And if you look at this Green Deal, you will see that sustainable, so-called sustainable mobility is one of the pillars. By sustainable mobility, you mean mobility that is green at the same time. So, and Fernando gave a very good exposition of the logistical challenge, and I will use this graph that we have prepared here, that you have all the actors here, the factories, the supply chain, the warehouses, and the big question again is how to do this, how to achieve this interoperability and maximum efficiency. And this is how we introduce the AEGIS project, which stands for Advanced, Efficient, and Green Intermodal Systems. So what we are trying to do here is to attempt a redesign of the logistical system by examining autonomous ships, automated ports, green advanced vessels, which will also examine digital connectivity and cybersecurity, and then we have a part of the project that deals with policy support and cost-benefit analysis. Some data for the project, it started June 2020. The budget is 7.5 million. It is in the context, as I said, of the Horizon 2020 program, and it has partners from 4 countries. Sintef Ocean is the leader. There are most of the partners are industrial partners, but there are also 2 universities. And then you have partners from Denmark, DFDS, the Port of Aalborg and Vordingborg, DTU, and partners from Germany, ISC, and also from Norway, MacGregor and Cargotec. So what we are trying to do in AEGIS is redesign the logistical system, examine new terminal concepts, automated cargo handling, autonomous and green shuttle, also digital connectivity and policy measures, and look at safety, security, and resilience. We have what we call 3 use cases, which are scenarios in a European geographical context that will be used to test, to examine what we're looking for. The first use case is short sea terminals in Norway, and specifically in the Trondheim area. And this is a preliminary design of what we call a daughter vessel in the Trondheim Fjord area, where this is used as a barge push convoy configuration. And you can see here, it is a very small vessel, 60 TEUs. Again, this is very preliminary, it may change. We examined several scenarios here. So this is the first use case. The second use case is Benelux, Ro-Ro short sea and inland shipping, Belgium and Netherlands, centered in the Antwerp, Rotterdam area, Ghent also, where again we examine mostly trailers, and there are several configurations where the trailers can be loaded on board the vessel. You can see 2 of them here, and again we have a convoy with pusher in this particular situation, where the barges are pushed in the canals and the rivers. And then there's a third one, which is involving the ports of Aalborg and Vordingborg, revitalizing regional ports and city center terminals. This is in Denmark, and here again we have some concepts here on containerized cargo, which we can see in this picture. So I mean, I don't have the time to go over the details of the overall methodology, but we start with the use cases. We do a logistical analysis. We examine technology, policy, and then cost-benefit analysis. And there are several work packages in this project dealing with logistics system design, autonomous cargo handling, the vessels, digital connectivity, policy support, and then cost benefit. Now, for this particular webinar, what is most relevant is work package 2, the logistics system redesign and resilience work package, which has the objectives that you see here. How do we redesign the logistical system so that we achieve these things that you see here, minimizing terminal storage, making better use of remote terminals, maximize automated cargo handling, including standardization of cargo units, increase frequency, and examine new automated work processes for digital exchange of data. And specifically for focusing on what we will be discussing today, there is the so-called task 2.2, the effects of standardized cargo units, where we focus on analyzing possibilities for more use of standardized cargo units in maritime and intermodal transport. And we try to estimate positive and negative effects of substantially higher cargo unit standardization, again, using these 3 use cases as examples. And maybe this is known, but I mean, we have already some standard sizes for maritime containers. We have the TEU, a 20-foot unit, 40 units, also the 45-foot, which is common in North America, but also increasingly common in other places like Europe. And the EU tried to harmonize the dimensions back in 1995. The discussion between short sea shipping versus deep sea shipping and competition, and the competition between containers and trailers. We understand that there had been a council directive in 1996 to see what kind of road vehicles can circulate within the community, and I understand there was a big discussion to what extent you could use, you can circulate, allowed to circulate the 45-foot container on European roads. But anyway, in the context of this task, we have prepared a questionnaire which we have circulated internally. Internally, I mean, within our partners and to the advisory group with these questions, which I understand will be also discussed later today. So I will be, very briefly, because I don't have too much time, going over, the preliminary results of this questionnaire, going question by question. The first question is, okay, what types of loading units are candidates or most attractive for the solutions that are envisaged in this project, low, or other? The answer is both. So we want to have an open attitude. We don't want to exclude anything. So depending on the use cases, some use cases use trailers and some use cases use containers. The second is what sizes are relevant? Is there any initial preference for any of the above? And the answer we got was that 45 seemed to be preferable in the sense that it can fit the trucks and it can be an alternative to road freight, which has about the same dimension, even though the 20-foot is easier to handle and automatized. The third question is, what are the key determinants of storage cargo handling efficiency? Which are the key parameters that should be studied? And perhaps this is not a surprise. The answer was the key parameters are cost and standardization. The fourth question is cargo unit standardization key for a more efficient cargo handling operational system? Who would benefit the most from it, small or big terminals? And the answer was yes, it allows automatization, and the main beneficiaries from at least the answers were deemed to be small terminals. And last but not least, anything else that we should be looking at? And there were a lot of answers here. First of all, automated palletized cargo is interesting. Lightweight containers are key to reduce costs, and staffing and sharing of containers could be key to utilize the containers in a more efficient way. So this is again very preliminary, and you know, we have not completed this task. We will be taking input to complete this task from this workshop, and I really look forward to the discussion. And thank you very much. I'm not sure how I stop sharing my screen now.
Should be a button.
I think I did that. Okay.
Excellent. Thank you, Lars. Yes, we haven't got the answers yet. We'll see today. Maybe we get some more answers. I think again, it was an interesting comment by Fernando. This actually the need to kind of divide and conquer, in the sense that. And I think also in the chat we have a comment that the economy of scale should be in the supply chain, not in the vehicles as such, which is a bit of the same. How can we optimize in the supply chains without introducing too much complexity into the system?
I guess the key word here is interoperability, because I mean, if you don't have, if you cannot make the systems talk to each other, you can optimize, you know, one component, and then you see that it doesn't really fit with the rest of the supply chain. So I think the key word here is interoperability, which you can find this word in many places in the European transport policy. But the key question is how do you achieve it? How do you maximize it?
Yeah. We can have a short comment from or question from Anton van Coyle.
Yes. Oh no. Just on moving trucks or trailers on vessels. If you want to be green, you don't want to do this, because half of what you carry is dead weight. So all ro-ro solutions are actually going out of the window if we want to be green. And the essence that people say that it's easy to load and unload, well, just at the waiting queues on the ferries to Dover, so you can easily do it by Lolo. It's just as easy and shouldn't cost anything more, especially if you can automate it. So again, I've seen these already in the past in Belgium, people wanting to put trucks on inland waterways. And what you then have is that the vessels become so big that the canals become small, and then your energy needs go up by 80%. So what's the use of moving trailers? So that's my remark.
Thank you.
I mean, people forget it. Inland waterways are not sustainable the way they operate today, because we've made bigger and bigger and bigger ships, which means the canals become smaller and smaller and smaller, and the energy needs go up by 80%. So you cannot go into alternative propulsion systems because your ship needs too much energy. So we need smaller ships in inland waterways. I would say class 4. But anyway, that's my remark.
Yes, I think we'll come back to that in the discussion. Our next speaker is Professor Nikos Ventikos. He is at the National Technical University of Athens, and he is also coordinator of the Moses project, and he will point at some of the possibilities within freight transport and how autonomy can attract cargo to waterborne transport. So maybe he has the answer. We'll see.
Hello, everybody. I think that I will only pose questions. I don't know. I'm not certain I will bring any answer. Let me just share my presentation. Let me just check here. And here. I'm just trying to find my presentation. Give me 1 second because I cannot find it. Where is my presentation? Give me 1 second, guys, because I can see it on my computer. Let me switch it off and switch it on again. Okay. Very nice. Here. Hopefully, I have managed to share it. Okay, so Ornalf, you can all see my presentation. Is this correct?
I have problems on my PC.
I can see it.
Yes.
Okay, super, guys. Thank you very much. So, good morning to everybody from, I don't know, sunny and foggy Athens. Today, my presentation will be focusing on what are the possibilities within the freight transport and how can autonomy attract cargo to waterborne transportation. As Ornalf said, I'm coordinating and I'm representing here the Moses project. I think that the Moses project does not touch so much some of the key points of this workshop. However, we are very much into social shipping and how autonomy and cargo handling will be affected by autonomy and all the recent developments. So, hopefully you will find my presentation interesting. Maritime transport. Okay, we are all keep on saying that maritime transport is efficient and green, the most efficient and the most green mode of transport. And this is mainly, I guess, due to economy of scale. We have already discussed and seen a comment on that. However, as we all know, and especially down here at South, land-based transportation is still preferred in some or many cases. And this is, you know, a topic that needs to be viewed upon. Why? Why does this happen? I believe that there are many reasons why. Just a short list would be that social shipping is a part of the whole supply chain, because here the key is the supply chain is not only a part of it, a leg of the transportation chain. So we cannot conclude the door-to-door delivery, which means that we have to change transport means, and this equals to administrative burden, increased transportation costs, and many other things. We have also the big liners that they might be associated with some delays. This delay will pass on to the feeder service, and at the very end, we will have a delayed delivery of the good to be transported. So this might be another issue. We have a complex cost structure. There are a lot of players, there are a lot of stakeholders involved in the process. So this makes the cost structure quite complex. And of course, the port close to hub ports. So we have big ports and some smaller ports around. They often lose with direct land transportation. This is what it is preferred. And of course, it's a matter of efficiency in the sense of capacity utilization. And this has to do, of course, exactly with what we will be discussing today, because we have the box. Is it moving fully laden? Is it full, or is it partially loaded, or what? So these four issues might be problems and explanations of why the social shipping is not preferred. Now, for the Moses, I will not go through them, through the whole, let's say, I will not present Moses in full. However, I would like to give the overall concept. The concept of Moses relates to many parts and bits of exactly of the supply chain. We deal with a docking of the mother vessel through an automated swarm, through an autonomous swarm of tags. These tags are controlled by a control station. We have, in conjunction with the autonomous swarm of tags, an automated system for docking. Then, let's say, magically, boxes are being shipped within the port, and some of them are found on a dock where they should be shipped to a smaller port. Imagine a port with no infrastructure at all. So we are designing in Moses an innovative feeder with a robotic container handling system. So this can, let's say, autonomously get the boxes on board. So we're talking about boxes, and mainly we are talking about, let's say, sources shipping. So in Moses, we had some discussions about open top containers or towards this line, but we are talking mainly about TEUs, about standardized maritime boxes. So we have the autonomous innovative feeder that goes to the smaller hub or port. We unload there the boxes, and the ship goes to the next stop and to the next port, and then it comes back to the main port. We have a recharging station because innovation here has to do also with the propulsion. So down the line, we have electrical feeder. And we also have, in relation to all this, we have this matchmaking platform, which we'll be discussing a little bit later on. It's a platform that tries to match and attract cargo from land to sources shipping in particular. Let me just also say here that because we're talking about Moses, that Moses actually stands for the project title, which is Automated Vessels and Supply Chain Optimization for Sustainable Short Sea Shipping. What do we expect? What do we expect about after the implementation of these innovations? That there are, as you can see, there are many and they are spread all around the supply chain. We have promised for a 5% minimum decrease of cost for container transport with feeder services, a 15% increase of feeder traffic between large terminals and small ports, and 10% modal shift to sources shipping in the designated areas. For example, we have two, up to date, we have two case studies, one in the Greek archipelagos, from the port of Piraeus to the port and the island of Mykonos, and the other, it's from Valencia to other two continental ports close to Valencia, to other continental ports in Spain. So one major thing that we are looking, it's autonomous tugboats with automated docking. Here you can see we are actually doing the virtual application of the whole system. Here it's on the Unity engine, and we are trying to put the physics in this kind of visualization age in order to be able to see how we can help the maneuvering and the docking of we have promised a 20% decrease in docking time for large container ships and 70% decrease in maneuvering times, because we are focusing on the maneuvering on the last mile, let's say maneuvering and docking of the big container vessels to the ports. So 70% decrease in maneuvering time for large container ships. Another interesting thing is that we are focusing, as I've already mentioned, to the innovative feeder with the robotic cargo handling. So we will have a robotic cargo handling system that it will load and unload boxes. As I've mentioned, we have been talking to date, actually, about TEUs. After we have discussed about this workshop, we have also started a discussion whether we should be, a little bit more flexible and seeing towards other types of boxes. However, we have no inland case study in Moses, so we are talking about maritime. We are talking about sources shipping. Transportation. So with this robotic cargo handling system, we have promised the 20% decrease of loading time for the feeder vessel, a 10% decrease of large crane usage in the deep sea, in the main hub for unloading feeder vessel, because we will not use the cranes from the port. We will use our own robotic cargo handling system. and 70% decrease in docking time for the feeder when, of course, combined with the Moses automated docking system. So this is mainly for the main hub, for the deep sea shipping port, and not for the peripheral ports to which the innovative feeder will be servicing. Okay, but all these are technologies. We are actually designing an innovative feeder, and it was very nice hearing Ornalf saying about smaller ships with autonomous shipping, etc., because our feeder will have parts of autonomous operation, and we are actually, let's say, designing smaller ships. We are designing ships of 150 or 200 or 300 boxes. So we are aiming and we are, driving down this road. On the other hand side, one of our business cases, as I've explained, is the Greek archipelagos, where what we are trying to do is actually shifting trailers, shifting boxes from the rope axis, because this is how boxes are reaching all of our islands, from the rope axis to this innovative feeder. So it's not like, shifting cargo from land to sea. It's changing the mode of and the way of the sea transportation, of the sea leg, of the specific transportation. So these are all technologies, but is this enough to attract cargo to source shipping and create sustainable feeder services? And sustainability here is in terms of steady cargo demand, which means that stakeholders will prefer constantly source shipping over other transport modes. Mainly it's road, but it's not the only. So what we have is we are trying to develop the Moses matchmaking platform. This is done mainly from our and the coding and the and the interface from our electrical engineering department here at NTUA. And the matchmaking platform here will be a digital platform for horizontal collaboration among logistics stakeholders, aiming exactly to attract and then to demand, to match demand and supply of cargo volumes. What we are aiming here actually is to have an alpha version for our midterm review meeting, which will be something like late February, beginning of March. So we are currently doing this exercise, and we are, we are developing the code and the interface. So the goal for attracting cargo to source shipping, as we can all see and know, it's to increase visibility of available source ship routes, to maximize demand, to clearly map the business-to-business processes within the entire supply chain, optimize the distribution routes, and improve the empty container management. This will also be dealt with through this matchmaking platform, and to change the freight flows handling and increase the partial cargo loads cost effectiveness. Partial cargo loads cost effectiveness is very interesting and something that we should be looking at. So who will be using this matchmaking platform? We guess more or less everybody: shipping agents, terminal operators, warehouse operators, freight forwarders, shippers, trucking companies, rail operators, the whole package. There are various features there, in the sense that there will be a route visualization and a web-based georeference interface, a selection of preferred user interaction based on needs, sharing empty containers information, cost-effective solutions, and scenario building capabilities. Now, the task that they will be performed is actually map and have on our database the ship rail routes, schedule and capacity publication, track services publication, the order requests, the information about available transport option, information about available matching options, order the execution and status monitoring, and finally communication with other stakeholders. Another thing that we will be trying to do, and we are trying to do on top of what we have promised in our agreement, was that under the, this physical, for example, physical internet let's say, in perspective, we are also trying to have this connection between the various modes and means and assets, which means with the tugboats in order to have the exact time of the docking, to, for example, the data from the innovative feeder to know exactly where it's going, where it is, the time and date of arrival and departure. And of course, this will be superly and only dedicated to the source shipping. Developed mainly for source shipping. As I've said, we have started discussing about the applicability and with other type of boxes, and we think that this is applicable and can be done, but we are just start thinking of that. And as I said, we are focusing on container freight. It might be customizable for any other modular logistic units. You know, the thing is, why do we need different? Because one fits all, or one does not fit all. Concept is that smaller boxes make sense when the capacity of big boxes are seriously or significantly underutilized, and this might be the case in, for example, some of the Greek islands. And of course, when the terminal space is not enough, or the equipment are not fit for this purpose. So we have, or we will try to see whether in our concept, in our let's say portfolio of activities, smaller boxes will be somehow referenced and dealt with. Now, closing. As you understand, the Moses project, we have technology, we have procedures, we have hardware, we have coding. We are talking about autonomy. Now, in an, how can I say, in an automated or autonomy reality, things could be different compared to the conventional reality. Ornalf has already mentioned that we might be talking about smaller ships. Of course, we are talking about scales, economy of scale. So, but they might be different. So we truly believe that the design of automated and autonomous technologies must be somehow very close linked and better linked from what we have seen today to the operation. And this is very, very important. We do not want to reinvent the wheel, even if we are reinventing it. We want to make our life easier and more efficient, which means that with this kind of solutions, we do not want only to reproduce solutions. We need novel interventions. We need novel solutions, and this comes also. It links very nicely to what Fernando said, that we must not only look to the to the past, but we have something in front of us. I would like to thank you very much for your attention, and Ornalf, I hope that I did not miss the time, because I am, I'm very famous of missing the time completely. Sorry, thank you.
No, it's fine actually. We have, I said it initially, we will not be that strict. We got a few questions in the chat actually, and it's kind of connected. And one question was, how the reaction from the kind of Greek ship owner, traditional ship owner environment. And I would actually extend it. Have you any idea how this new type of system, and I'm thinking about the whole system with the smaller ships and this electronic platform, how is it being received in the logistics community in Greece?
We keep it a secret. No. Okay, changing a way of operation that has been done and succeeded in the last 40 years, it's not such an easy topic. The thing is that we have ports like Piraeus and smaller ports like Mykonos, Tinos, Naxos, various ports that they are very interested into this concept. And we have some kind of, let's say, for the time being, some open ears towards shifting, this kind shifting this kind of operation from the rope axis to this innovative feeder. The problem is they are happy, and why this is done, because they are quite happy to do so during the summer and the touristic period of the year. But the year has 12 months, and in December or January, this is a big, let's say, source of income for the rope axis as they are operating right now. So this is something that poses some friction, but we are trying to deliver and promote this idea, and we will see how this will be done.
Yeah, and I think there was also another question on how this platform, how do you think that will be maintained after the project is terminated?
Yeah,
will it be
yeah.
versatilized or?
Okay, we have been talking. Actually, the electrical engineering department of NTUA, a team of there, it's a part of the ALICE platform. So they are very much into this kind of commercialization and approach for this kind of let's say of products. Now, yeah, I do not have an answer here. What we will be done is actually we will what we have promised is the beta version of this matchmaking platform. And from there on, I think it's a discussion that will be held towards the end of the project of the Moses project to see how this will be done.
There are some other questions, but I think we need to get back to that later.
I will try to reply to them through chat. Okay.
Yeah, particularly
Cheers.
the more technical. Thanks.
Thank you. Cheers. Thank you.
Our last presenter, not least, I would say. Perhaps we will get at least some ideas from this presentation. Ton Bertens is the Research and Development Manager at Vanek Trailers. We'll give an overview of some results from the Cluster 2 project, and in particular the new modular loading unit concept being developed there. Ton?
Yeah, thank you. You hear me well?
Yes.
Okay, I'll try to share my screen. Can you see my screen?
I think it's okay. Yeah, there we are. Thanks.
Okay. I couldn't switch on my camera. I don't know why.
And that's Teams for you.
Okay.
We'll find your picture later.
Okay, yeah. Okay, my name is Ton Bertens. I'm the manager of R&D at Vanek Trailers in Holland. And Vanek Trailers is a trailer builder experienced in automated loading systems, like roller tracks for air cargo, as you see here in these pictures. We also build trailers to optimize the maximum volume that can be used inside a trailer. Double-deck trailer front is an example of this. The experience in the field of ULDs for air cargo was also the base for the NMLU, the new modular load unit. In the clusters project, the challenge was to come up with an idea about a load unit between the trailer or an ISO container on one side and the pallet, the roll container, or the crate, like here the Modulusca crates on the other side. So we were looking to a unit between those two cargo units. Out of the investigation in the clusters project, we want to introduce to you then the NMLU. The NMLU can be the new standard in the logistics supply chain. It has interfaces to make shelves in it, so that you can put cargo at multiple levels. But it also has connection to the physical internet. A built-in chip will follow it and see its cargo along the journey that it will make. We also think that combining cargo like pallets or crates in a clustered module will increase the efficiency of vehicles or in a trailer or in containers. If you take a look at the first trailer, filled with heavyweight pallets filled up to the max due to the maximum weight. The other two trailers are filled with the yellow pallets, but they are filled up to the maximum due to the volume. If now we could make from those red pallets and yellow pallets a modular load units, and you could shift these loading units in different trailers, that's what we call horizontal collaboration, then you can put all this cargo in two trailers. So you would gain about 33% of loading efficiency. So this is the idea that we have of the new modular load units, but these are then just self-standing load units. And what we also need is then a way to combine those units when we go transporting them in shipments. And that's when the idea of the subframe came up. So if we could fix those NMLUs on a subframe, we can handle the complete subframe in the logistic circle. On the subframe, these NMLUs will be connected together. They will be secured on the subframe. You can automatically load them on the subframe with roller tracks, and the NMLUs are then one unit as big as a container. This subframe is then also the base of our next development, the NMLU container. And the NMLU container, as you see here on the left, is then the base for transport over road, over rail, and even also over water. And this subframe, this container can go on trains, as you see here, but can also go on boats. The subframe can also be the base for city delivery. If this subframe will be placed in some different positions near cities, you can take the NMLUs from the site in little vehicles and go into city distribution. In this project, we designed 4 types of NMLUs. This is another picture. We already had a lot of projects busy with designing new modular load units. And our question was, are we now already designing the 40th type? All of them stranded after the first designs and never really came to the road. And what should we do different on this? And that is that we designed 4 types of different NMLUs depending on their use case. But what they all had in common was the same base plate. The base plate, as you see here in the middle, has pockets for securing the load. It also has pockets for forklifts to handle it. And it has here on the side, let me say, a self-securing shape. So when the NMLU is going in the container subframe, it is automatically secured. You just slide it in over the roller beds and the NMLU is secured in the container. So this base plate is the base for 4 different types of NMLUs. We first have the panel NMLU. In this panel NMLU, you can at different levels put in pallets or roll containers or crates. And then it's a closed box. This box you can put near warehouses or shops, and then it can be a self-operating unit. The NMLU can also be a part of an ISO container, an ISO container chopped in 4 pieces or in 5 pieces, but then again on the same base plate. So it can be handled in systems that are now valid for air cargo. Then we have what we call the modular NMLU, and we have the Modulusca NMLU. And I want to go a little deeper in the modular and the Mollusca NMLU because we did some prototyping and tests with it. With this modular MLU, we really need to be forcing a little bit the standardization in heights. The idea of this modular NMLU is that the articles are packed on pallets and then a hood is coming over it. And this hood is made so that you can then stack the pallets on the hoods again. So you can fill these NMLUs up to the top. But you also need to force a little bit the standardization in height of the products that go into the hood. If you see here, the pallets can be stacked on the hoods, and there are interfaces to fix them while transporting the NMLUs. Here you see the same base again to pick up the NMLU when it goes into the logistic circle. On return, those hoods can be piled in each other, the pallets can be stacked, so that there's also then a unit of empty parts for this idea of the NMLU. So for the modular NMLU, we built some protos. We could stack them on each other. We could slide it over the packages that were on the pallets, and we could transport them in warehouses, in trailers, and automatically get them into the systems of the warehouses. The other idea is the NMLU based on the Modulusca crate. The Modulusca crate you see in here. And the Modulusca crate was a closed crate with a system to be attached to each other. So those two crates could be attached to each other by grippers. And then you had a complete pile of maybe 5-6 Modulusca crates. But that was also for us a little bit the disadvantage of the Modulusca idea, that there was no way to handle those pile of crates in the standard logistic supply chain. What we came up is a kind of Modulusca box which was opened and could be piled on each other with different dimensions. But in the end, if you had piled up the Modulusca crates, you always end on the dimension of an Euro pallet and one fixed height that is closed with a top plate. So what we then is make a kind of Modulusca pallet, and these pallets are piled on the Modulusca base plate. And that would then be a new way of handling goods in our supply chain. So these Modulusca boxes had all dimensions based on 400 by 300. They are a multiplication of all those dimensions. And depending on the sizes of the products made that would be packed in it, the Modulusca crate can be chosen. Then you can fill the Modulusca pallets until it's always completely filled. And in the end, you can always end with a flat surface, which then has a top plate. The Modulusca boxes are open on the top. They have like the Lego boxes, an interface that they can be stacked to each other and then are always fixed on the pallets. So if you see this NMLU, it can go in all our standard systems. So you see the Modulusca NMLU in a warehouse where there's automatic loading of trailers and containers. It fits in there. Also the Modulusca pallet that can have different dimensions of different Modulusca crates, but it's always a pallet of 120 by 800 and can go into the standardized systems that are now in the warehouses. As you see here, the Modulusca crates can also automatically be handled in warehouses. They can be unpacked by robots, and in here then the products coming from a supplier will be packed out of the Modulusca crates automatically and go in other crates to go back in the circle to the shops. From the Modulusca crates, you can also make a kind of roll container that you can then use to deliver the different type of different filled Modulusca crates to the shops. And here in the end, you see we also had some ideas to put Modulusca NMLUs in the city delivery. Yeah, there are new ideas about city delivery vehicles. The NMLU would fit in there, or the NMLU pallet would fit in there, or even the crates would fit in the current systems of delivery to customers. And in the end, that would be our idea of the complete supply chain for fast-moving consumer goods. It starts here in the production plant. There are Modulusca crates. The products are packed into the crates, and they go on the Modulusca pallets. From these pallets is made an MLU, and this MLU can go in a container, go by train or sea, comes on the truck again, and then ends in the retail distribution center. But also these PO pallets can go directly in a trailer and end at the cross-dock. Yeah? And the big advantage of the NMLU is then that the transshipment of all those different NMLUs is very fast, is automated. You can combine different NMLUs from different customers in one shipment. That's a very big advantage. And in the end, the Modulusca crate will end here in the retail DC. It will go directly to a customer when it's delivered. The customer then gives back his empty Modulusca crate that goes back. And the Modulusca crate can then here go into the local production plants and start his travel through the logistics supply chain again. This is what we, in the end of the project, did with the two different type of NMLUs that we made prototypes. You see an NMLU with crates, you see an NMLU with pallets, and we did testings in automatically load the NMLUs. They go from a roller bed system automatically in a roller bed trailer. They also can come out of it automatically. They go over the existing roller bed systems that are now for air cargo. If they go into the Modulusca container, they are automatically sealed here, secured with grippers that's in the shape of the bottom. And also the container can be handled very easily to go from a truck on a train. And that would also be easy to do it from truck on a boat. That's our presentations of the NMLUs that we have and the ideas coming out of the clusters project. Thank you.
Yeah, thank you. Very interesting. I'm not sure if it will solve all our problems, but it seems to be heading in the right direction. One question I have in general, and I think this is a really nice idea. How do you think the market will receive it?
Yeah, the problem with the market is of course how to start it up, because for these Modulusca crates, you have you have to have it in every cycle then. There's everywhere in the complete supply chain you would need those crates to make it profitable. So our idea is that we should slowly start it with a company who is already doing goods in crates, and then gradually start from there and spread it out, because that would be the biggest problem, how to start this idea up. Now all goods are packed in cartons and sealed with plastics, and you all wouldn't need it anymore if you go over to these Modulusca crates. But the problem is, a point to start.
Yeah, I think we should start our so-called panel discussion. And Fernando, I'm not sure if you are at all able to answer this, but I think there's a lot of very good ideas there. Do you have any feeling about how we could make these good ideas be more accepted, or find the best idea, or whatever?
Yeah, it's very complex question. I think here is always that there is this valley of death between the ideas and prototypes in projects and market readiness. I think one of the issues we see in AEGIS is that focus on the projects are in technology readiness levels. And I think there are many other aspects in the market dynamics that are not considered and are at the end either favoring or killing the ideas, and they are not worked around in projects. And this is something that we are working in the BUSLOG project ourselves, trying to make more recommendations on that, because this is very general. And then what we see, for example, in BUSLOG is that out of the projects you need, after the projects, in the best cases, 3 to 5 years to get those results, applications, ideas start to be in the market. So then there is a huge gap, and the idea is how to reduce that gap to make it. But the how is not clear yet. But I think first step would be recognizing technology readiness levels are not enough to define impact into the market, and I think the example from Tom was very clear. Then the other point is that for some innovations to happen, there is a lot of coordination and collaboration to agree on changing on a paradigm, and there it's a different, as Tom described very well, what is needed already.
I think I think you are mentioning some very important points, at least. Tom, on if it's possible to stack standard containers on top of NML U-frame, just the system.
Yeah, you see the type of the type B, the container NMLU. These are stackable, so they are made on the outer dimensions the same as the ISO container, so they are stackable. The one with the curtain side, they are not stackable. And
yeah, exactly. Going back to this question of market uptake, so to speak, Harry Lars, do you have any? I mean, you have been in the business for a long time, and the question of where is the gap between technology and market uptake, and is it possible to do anything with it? Policy measures.
I agree with Fernando that there is a gap, and the big question is how to close the gap. I remember when I was at the port of Piraeus many years ago. The port was participating in that was many years ago, in some research projects, and I was given a very nice demonstration of a simulation of the container terminal or whatever, and it was very nice. And then I realized that this had very little to do with the real world, and the question is, what do you do? What do you do to bridge the gap? And I think involving industrial partners in this research project, I think is the key, because I mean, we academics sometimes have the tendency to produce all kinds of abstract models or whatever, but you need to connect with the people who are doing the stuff, and coming back to your question, I think you have to develop some credible business cases so that we can see what are the obstacles, what are the bottlenecks, and how it can be pushed so that because if people do not make money out of this concept, they are not going to use it. So you have to develop a credible business case in all situations.
Yeah, Fernando, you have a comment? You are muted.
Yeah, sorry. Yes, here the comment is what we have seen also in our in BUSLOG, is that there is something important that in the projects to make this closing the gap. It's important to have the users already involved in the project, but also the ones that maybe the pod are going to facilitate that, but the concrete companies that are going to exploit that innovation, so that the innovation is going to be mainstream into their business case, or they are really, the day after the project will continue to invest in either that idea or something similar go to market. And there is where we also see in many projects we lack that very clear role in which the company that is really going to go beyond the project to really address that particular problem in future. And we see the projects that have those stakeholders are normally much better position into the market in the future, and eventually, even if the solution is not reaching the market, it's always a good way that the development in the project is going in the right direction anyway.
Nikos also have a comment.
Yeah, I just want to echo what Fernando and Professor Safdis mentioned. I think it goes beyond in the sense that if you want to use a ship, or if you want to develop a procedure or something, or a supply chain or whatever, from the beginning, from the early design phases of the asset that we are talking about, you should have on board the users of this procedure, of this vessel, or whatever. Because this is how, when we design something, I'm certain that if I'm designing a ship, if I'm designing a supply chain, I design it, at the end I say that everything is perfect. However, the users of the ship, or the users of a procedure or whatever, they say, who designed this thing? He doesn't know anything. So integrating and involving the users from the early stages is of utmost importance in all levels of design. Thank you.
Yeah, I tend to agree. However, I saw some figures that the stock value of Amazon is about 3 times the value of all the world's ships, which kind of indicates a potential power from the supply chain owners. I think one problem also may be that we perhaps look more at the transporters in some of the projects than the supply chain owners. Any comments to that? Nobody wants to. It's a difficult question, I think. Jan Tore, you have.
Yes, I raised a hand, and I mean, we learned a long time ago that cargo is king. Those who are driving this are those who owns cargo, not those who moves them. They're just doing what they're told.
Yeah.
Yeah, that's basically also my view. Anton has raised a hand.
Yes, my experience with people who run logistic chains are that they are low-grade managers who have no strategic views, except the KPI is it has cost nothing. And a lot of the cargo owners just gave the process away to those people. Now they're starting to think differently because there are other strategic elements that come up except for cost. Think about green, etc., etc. But there is a real need to educate logistic managers or the people that run the strategic point of on that sort of thing. Because the majority of, as I said, it's been dreadful. The only thing is cost. And you have somebody who uses the most dreadful system, but it's 10 cents cheaper, they will go for the 10 cents. And that's what we need to do. And that's part what the academia needs to do.
Yeah, and then the next question becomes, okay, what about development and sustainability goals? Will that, what kind of effect will that have? Because that, at least in theory, it should put green transport in the forefront.
It is happening now. We are talking to clients who want to have zero emission ships within the next, not 20 years, but before 2030. I mean, we're changing letters of intent on this.
Yeah, we see it also in Norway, of course. The two projects we have on autonomous ships is actually driven more or less by green. Fernando, please.
Here, the question I have is, I will see, hopefully we have these assets running already in 2030, but which part of the assets will be transitioned by 2030? We see maybe more in other industries. Everybody wants to have a hydrogen or electric truck or whatever, but yes, having one or two or hundreds, it's not making the difference on the objective. So then maybe you have one, but how long will take to transition all the assets, and there is where I think we need to find a way to accelerate that, because we see all announcements and all that, but then the fraction covering the scope of the announcement is so small compared to the size of the problem that sometimes this is jeopardizing the whole issue or problem.
Arnulf, may I add on something on that?
Yeah,
yes,
sure.
Short.
The most modern inland waterway fleet in Europe is the Dutch waterway fleet. They have 6,700 dry bulk and container vessels. 70% of those vessels are on average more than 44 years old, which means they have to go out of use by 2030. That's 2.5 million tons cargo capacity at, let's say, an average of 1,500 to 2,000 tons. Therefore, we need in Europe to build about 2,000 new ships in the next 10 years. This is the economic leverage of going green. But the main problem will be the people that have the assets, the legacy assets, and the people behind them who do not want to change. But there will be a social problem on inland waterways in Europe. Yes, absolutely. And that's what we need Europe for.
I think Harry Laos, we tried to give a word to him.
Yes, I have a comment on the whole drive to decarbonize shipping, because I have been following the IMO discussion over the last X number of years. And in fact, there is a meeting of the IMO in a couple of weeks that will continue this discussion. In my opinion, the discussion at the IMO is going extremely slow, mainly for political reasons. There is a wide divergence of opinion on what needs to be done. To give you an idea, last June they have decided on some so-called short-term measures, which are the purpose is actually to reduce the so-called carbon intensity of maritime transport, which is the ratio of CO2 divided by the transport work, in order to meet this intermediate target of 2030 to reduce carbon intensity by at least 40% versus 2008 levels. In my opinion, this short-term measure will not achieve that much. I mean, what is more interesting is the discussion now about the mid-term measures, which include also market-based measures, because you can talk about alternative fuels, and there's a lot of discussion about hydrogen, ammonia, and all these other fuels. So long as the price of fossil fuels is low and affordable, people are going to use them. So who's going to use these much more expensive fuels if they're going to get bankrupt? So I think in that respect, the discussion on market-based measures, which has started, I think is very important. Of course, it's going to be also an extremely difficult discussion. And now on top of this, you have all the discussion that is going to take place in the European Union about the inclusion of shipping in the EU emissions trading system. which is there has been a proposal last July, and also a proposal about alternative fuels. So I mean, there's a lot of discussion going on right now, but at the IMO level, at the global level, it's kind of difficult, mainly because of political reasons. But I think you know, the research is being done in these projects is very relevant because you can improve your carbon footprint by operational measures and by being smarter, which is I mean something that these projects are looking at this point.
Just sorry, but if the IMO does move, it will become irrelevant, and there will be other organizations who will take its place. And if in Europe we decide to go green, and you're not, even if you're with IMO who says you don't have to be green, you won't be able to sail in Europe. So, you know, if IMO doesn't get its act together, it will become irrelevant.
Well, it's extremely difficult at the IMO. I mean, it's you cannot believe what you hear. I mean, I'm always frustrated when I attend these meetings.
It's another discussion, I think. IMO. Anyway, there was one comment in the chat about e-toll on the roads, and I think another issue I see in Norway is that we are investing about 20 times as much in roads as we are in sea infrastructure, in spite of having about equal ton miles on both modes. But Fernando, please.
Yeah, I only wanted to add, and I would like to really know and get more information on if this transition of the assets in the Netherlands, then there are available technologies that are competitive already in CapEx and OpEx, and the infrastructure is there to transition all those assets, and what should happen really to make that transition of the assets in the next 10 years, and without putting more burden into the inland waterways transport in terms of cost, because at the end it's a different problem. When we look into the road, its transition in the assets it's very important, but in inland waterways transport or rail, if we create, by transitioning the assets, we create an additional burden in terms of cost or pricing, we may get more complex to the primary way to decarbonize freight transport and logistics, that is really bringing more cargo into these transportation modes. I mean, by getting more cargo on these transportation modes, you get already reductions of 50, 60, 70, 80% of emissions, even if it's on conventional fuels. If by transitioning those assets we make it more cost, then this is something that we also need to have into the equation. But happy to hear if that's already a win-win situation in which transitioning the assets to zero emissions is also reducing cost of the operations and cost of the transportation for the users. Of course, that would be great.
Fernando, to think that the way inland shipping is green is a fallacy. A truck, a Euro stage 6 truck, is less emitting than the most of the vessels running around in Europe. So when people say that, they never talk about the actual use of the energy on the vessels. So we need the new vessels in any case. But the only way through is autonomy, because by taking the crew off, we create the economic margin to pay for the more expensive energy systems.
Good idea, yeah.
Yeah, it's and we see the same picture also in short sea shipping in Norway, with at least for the bulk segment. It's a lot of small old ships, and the necessary investments for a ship is quite high compared to a new truck. And so it's a really tricky business, this. And as I tried to say, I think also the society subsidizes road traffic quite heavily through investments in infrastructure that is, in a sense, for the voters, but also used by the trucking industry. But that's another matter, perhaps. Any more comments on this issue? And I think another question here is, can we really afford that all this transport is now moved from old ships to trucks? How will that impact the infrastructure? Do we have capacity for it? Because that may happen. I saw Harlaus figures.
I think it's a kind of impasse because, I mean, if you continue to move things into the roads, then you're going to need to build more roads, and then there's more traffic jams and all this so-called external costs that they are talking about. So long as they are not internalized, then you continue to have a problem. I think a solution is to externalize. I mean, apply the so-called polluter pays principle. Meaning that the polluter, in this case, trucks, who are the biggest polluters right now, they pay for their pollution. How do they pay? Well, you increase the you put a toll or whatever but it's not going to be easy because there are a lot of vested interests in the automotive industry and the trucking industry that are not going to look upon this in a very favorable way. And they have, I think they have more power than the power of the shipping industry or the inland navigation industry or the rail industry for that matter. So it's not going to be easy.
We know that. Any more? We have a lot of comments here. I'm trying to find out if there is. I think one thing we could perhaps return to is this discussion of RoRo versus load on, load off. I know that Anton has strong opinions on it, but the fact remains that RoRo is quite convenient in terms of cargo handling. Any opinions on that? Tom, for instance?
I'm not a RoRo operator, but I mean, we have a partner in the AEGIS project, DFDS. I don't know if they are in the audience. I think they can defend themselves, because as I understand, Anton's argument is that the RoRo sector should not exist, which I think it's an easy argument. If it doesn't exist, what's going to happen to the cargoes they carry? I mean, are they going to go somewhere? Are they going to disappear or somehow, or what? So, and I think just let me finish. I mean, in the AEGIS project, we have this cost-benefit analysis where we're going to examine all this scenario, and we'll let the chips fall where they may. We have already made some preliminary analysis that show what KPIs are improved and what KPIs are not improved by shifting to inland navigation. So I'm not speaking for them, but I think they should be allowed to tell us their opinion.
I agree with you. I'm saying that, but I'm saying that if you take stuff from Antwerp to Hull or Immingham using RoRo, it's totally inefficient on a energy basis. If you go from the Isle of Skye to Mull, and it's a 10 kilometers trip, then yes, it's much better to do RoRo. Why do you need to move trucks on ships on Greek islands where you could have a very small crane doing low and have a local truck running on hydrogen or electricity to do the short distances? I mean, it's very inefficient to have this piece of equipment standing still on a vessel. I mean, for 2 days or something like that, apart from the energy bees. So But fine, you do your study and you come out what you do, but do look at the energy used for moving the same amount of net goods by using containers as opposed to trucks. Go for it, study it.
Am I allowed 1 minute just because you mentioned the Greek islands? I mean, every summer I go to this small island of Sifnos, which is in the middle of the Aegean.
I know very well.
You've been there? I don't know.
I see. Gerrit?
Okay, so all the goods that are consumer goods, the supermarkets or whatever, they are transported by truck. I mean, the trucks are stuffed into the Ro-Ro ferries, and you have actually big trucks coming. And there's a lot of problem with the traffic situation in the island because the roads are very small. But there is really no alternative. You know, what are they going to do if they don't have this thing? I mean, what you mentioned, cranes and all that, it's not going to work.
Well, look at what is happening, what Nicolaus is doing. You have a small gantry crane that takes 20-foot containers, small trucks, which because they're small, because they do short distances, can be electric or hydrogen based. And you have a pool of, I don't know, that's something you calculate, 10 or 20 of these trucks. And they'll be used very efficiently, continuously, instead of a truck which is coming in full and then going back empty, and going back empty back to the mainland. I mean, how ridiculous is that? The only people that like this are the ferry operators. You know, think differently. Once we go digital and small, we can work totally differently.
Okay, I'll talk to the truckers and see what.
Don't talk to the truckers because they want to have trucks that stand still because they're being paid for standing still. I mean, can you imagine how stupid it is? And then you have to put all these truckers on a vessel, which means they have to eat, they have to drink, you need to have toilets, you need to have sanitation, safety equipment. I mean, all that cost, get rid of it. It'll be much.
The maritime sector need also to really become aggressive here. I mean, you're all talking about vessels, you're talking about boxes like we're talking about now. You're not talking about really properly integrating this into chains. And you have to do that, because if you don't, it's easier to call a trucker and get an ETA than knowing what the box ETA is when you're going by sea. And I think this is not the rational things. It's that all these things that people are really relating to, and I've been there for 25 years and I haven't seen 1 ton of cargo being moved from land to sea for 25 years, not 1 ton.
It's the opposite.
Exactly going the wrong way. Fernando, please.
Yeah, I just wanted to say basically that what you said, Anton, makes all sense from a rational point of view. But then changing the paradigm cannot come from one or a few stakeholders. This requires more strategic thought and also it's very complex. So then you cannot, a single stakeholder cannot act and do all that change. That needs to be concerted action, and this concerted action, it's a blocker always for any kind of initiative. And the question is really how you can work around a clear way to make that transition happen, and to convince the asset owners and the system itself that they can have a piece and contribute. That's essentially what I see. It's an issue, and from single initiatives, it's very complex to do that unless you have a very overarching framework for collaboration to really propose those kind of system upgrades, I would say, from a full system perspective.
No, I agree with you, but let's be frank. The asset owners, if they don't want to follow, they go away, they go bankrupt, they will disappear. I mean, what happened when sail went into steam and went into diesel, when horse carriages went into trucks? I mean, you know.
I think it could happen that, but also a big guy in one of the companies told me always, we have been said for 20 years, this will change, but the ability of the old players to keep in business doing what they were doing, it's amazing. So it may be a turning point, and we need to find a turning point for that. But only telling they will go out of the business, and I don't think this will really create the change path. We need to find a smarter way to really move into that. Just not telling them you will go out will not be enough. That's my, hopefully, I don't know, maybe, as you said, in 10 years, everything is green and everything has transformed, and we are very good on track for climate change because people not going that have gone bankrupt, and the ones bidding for that are making it great. But my personal opinion is that this will not happen spontaneously.
The only thing is we are at a, what is it called, when crossover, the water flow crossover with the environment. I mean, you know, COP26 and all these things. We're at a watershed, and some people will follow it and others won't. And that's what's going to happen. But this will be evolution in the same direction. That's the only thing I can say.
Can I show you a picture?
Yes.
Just to give me a second.
I think we are in a sense back to the business case and convincing the business case owner that this is a good idea, either by force or by, yeah.
Okay, so this is the big truck logistics in Cyprus. I mean,
this is ridiculous.
No, but this is what's going on every summer or every day, you know.
Well, this is where there's the opportunity.
Well, you tell me. I don't know.
Okay, we'll get together and we'll set up a plan. Yeah.
Guys, that's why the Commission has, you know, the Moses project, exactly for this kind of issues.
Well, you see the vessel behind me. That's the one we are developing for this.
For Idla.
180, 200 TEU, zero emission autonomous vessel.
It will be
interesting. I'd love to talk further with you guys.
Yes. Sure.
That's, I think certainly this, it was a very interesting discussion. I think we didn't really solve it, but I think we are pointing to some of the major issues. And I think cooperation and talking together probably is one of the most important here.
Absolutely.
So we hope that the COVID pandemic disappears so that we can do it for real. Fernando, please.
Yeah, I think there is a lot of good thought also in the chat, very good ideas and the discussion. And my question would be to what extent Moses and AEGIS will digest all this and create a nice report and work on this, because this would be really great that in 6 months or in a year we can see, okay, this is what we gather and to make more. I think one of the issues we have is that the concrete problems are not well defined or visible, and I think that would be a good contribution already if AEGIS and Moses could make these problems more concrete, visible. I think the picture from Arilaus speaks by itself, and also the good ideas that were presented as typical solutions. But I think from your autonomous vessel to work, Anton, there are other aspects in the boundaries of your system that will also need to change, and that there is where I think we need to make this more holistic. And I hope through AEGIS and Moses you can work on that. I'm happy to create ALICE as a platform for further outreach.
Absolutely, I agree.
I think we probably need to include the Watership project also, Anton.
Yes. But there it's mainly on autonomy as just this is going wider. But I agree with you. And the Autoship project is part of it, but it's limited in the whole sense. Yeah, I agree.
So I think that sums it up. There's a lot of good ideas. We are not quite sure how to realize it, but we see there is a future. Any final words from anyone? I think this is, I wouldn't call it a series of webinars, but I think we will come back to some similar event a bit in half a year's time or something. At least to see where we are in
yeah, we have to.
relationship to Fernando's proposal. Paola? This?
Yes, good morning. I work for the European Commission, DG Move, so DG Mobility and Transport. So let's say this part of these, the projects you have presented today have been funded under topics that we have been proposed. And well, first of all, I would like to thank you for the presentation and the discussion that I found extremely interesting. I'm just slightly upset that we go back to a bit of the usual problems that I hear in different sectors and in different webinars and conversations and presentation of projects. So I fully agree that it's necessary to involve in projects end users. I was a project officer 10 years ago, and I already was trying to encourage projects always to look at end users, to have conversations. The question is, how can we help you to have end users in your projects? So this is, for me, is a very important point. The second, I understand that we write topics in a way that very often focus very much on development of technologies, and this is very, very important. I fully agree. What I think we're trying to do now in Horizon Europe is to look also into organizational change. How can we, how can actually you as experts also can help end users, operators to understand that it's necessary to change? How can you help to these end users to adopt innovation? So what can we do? We are aware of this valley of death. There are calls, for instance, in a Connecting Europe facility to address partly of this. But I would really very much appreciate it. I mean, I'm coming really at the end of this workshop, but in future webinars, if I may to please, one, keep us informed. I saw this a bit at last minute, and I'm really sorry I was not in time to forward the invitation to my colleagues from the maritime units, from the waterborne units, because also they would like, I think they would have been thrilled to know about these projects and what you are proposing. And second, to let us know what we could do in future topics or other activities in policy and regulations, really to help this progress towards innovation, towards more sustainable activities. So any input is much more than welcome. So thank you very much. And I'm really sorry I was about to leave because I have a meeting in a few minutes. But thank you again for this extremely interesting webinar.
Yeah, we will put it on web. It's recorded, so it will be available afterwards. And I think just to close the whole thing, the reason why we are sitting here together with Alice is exactly this thing to see how the technology we are focusing on in our 2 to 3 projects better can be integrated into the logistic solutions. So we hope we can make some progress on that also. So I think by that we will close this webinar, and thank you to everybody, presenters, listeners, commenters, and everybody. If you have questions, feel free to send us an email or call us, and we'll put you in contact with whoever you want to be in contact with, and so on. And good suggestions are more than welcome from everybody, and we'll take up Fernando's proposal and try to make some kind of summary of this.
More homework to us. Thank you very much, Fernando. Thank you, Ornar, for the moderation. Thank you very much. Thank you, guys.
It's a matter of impact, so then that will for sure get you closer to impact. Thank you.
Thank you. Thank you.
Take care, you guys.
Bye bye.
Take care.
Bye.